Hello everyone, my name is Bindu. Today I'm going to share my project, and my title of the project is Silent Intruder: An Approach to IP Spoofing by MITM. Cyber attacks have become a significant challenge in today's digital era. Among these, IP spoofing within the man in the middle attacks is particularly dangerous, allowing the attackers to intercept and manipulate the sensitive communications. In an MITM attack, hacker positioned themselves between the two communicating parties, intercepting and altering the data without their knowledge. By using the IP spoofing, attackers impersonate trusted devices, exploiting the vulnerabilities in unsecured, poorly configured networks. The major risk, the major risk assigned using by these attack is data interception, message manipulation, and financial loss and identity theft. The attack can target individuals, business, or even governments, leading to severe consequences such as data breaches, fraud, and espionage. For this project, for this project, we simulated an IP spoofing attack in a controlled environment using VirtualBox. We created three virtual missions: a Linux victim, a gateway, and a Kali Linux attacker. Tools like AttackApp and Wireshark were used to execute and analyze the attack. The attacker starts by scanning the networks to identify potential targets, including the victim of the and the gateway. Once the targets are identified, ERP we can attack ARP poisoning and also ICMP redirects and whatever attack we need, and it is initiated to intercept the communication between the victim and the gateway. The attacker uses Wireshark to capture the unencrypted HTTP traffic. This allows the sensitive information such as login credentials to be extracted. From the captured packets, the attacker extracts the plaintext credentials, highlighting the vulnerabilities of unencrypted communication protocols like HTTP. After implementing these defense mechanisms, we observed that malicious traffic was effectively blocked. Credentials were no longer accessible and the network's integrity was maintained. As here we could see that the username and the password of can be seen. This is how the attackers will hack the devices. After implementing the defense mechanisms, we observed that malicious traffic was blocked, credentials were no longer accessible, and the network's integrity was maintained. This project demonstrates the critical main importance of cybersecurity measures in protecting networks from IP spoofing and the MITM attacks. By combining the encrypted authentication and the continuous monitoring, we can significantly reduce the vulnerabilities. Here, as we could see that the username and password of the user can be hacked. The conclusion is it demonstrates the attacks exploits routing the vulnerabilities to manipulate the network traffic, defense mechanisms including disabling the ICMP redirects, configuring firewalls, and applying static routing effectively mitigated these attacks. The monitoring tools like Wireshark and AttackApp can be used to identify whether there is attack happened or not. Firewalls and static routes can help to secure the device. Thank you.
Hello, this is my presentation on the ARP poison attack, part of the IP spoofing group. My name is Dalsora. So ARP is basically associating the MAC address with the IP address of any given device. So what the ARP poison is an attacker can manipulate those ARP packets and change those MAC addresses to its own MAC address. So when it does that, the Windows machine will think the default gateway's MAC address is the Kali Linux MAC address, and vice versa for the default gateway of the router. So here I did a attack demo using the VMware software with a Kali Linux and a Windows 11 virtual machine. So in the top left of the picture, you can see I have the Kali Linux to my right, and I use a uh, software called EtherCap, which allows to implement ARP poison attack by scanning the network for the devices. And you just add the target and click on ARP poison, it will do the attack. And if you look to our right, you will notice an unsolicited packet will occur if you look at the first ARP packet using Wireshark. The opcode reply to means it's an unsolicited ARP packet. Basically, it's sending to the Windows 11 even though it didn't even ask for the ARP packet. And if you compare these two ARP tables, you can see that the default gateway MAC address is now changed to the default to the Kali Linux MAC address. There's three ways of defending against this attack. The first way is static ARP on the user PC. You just do a simple command on the command prompt of the PC. The most important one is the second one, which is dynamic ARP inspection for DHCP. DHCP basically gives automatically gives the devices its IP address in the network. So it will have its own table, and you go based off of that table to match the MAC and IP addresses of those devices, and you will know if there's a incorrect MAC address associated with the IP address. And this would happen in the switch. And the third way is basically doing the same as the PC one. You just do a simple command with the static ARP on the switch. And that was my presentation. Thank you.
Hello, my name is Joshua Lopez, and I did the IP spoofing Smurf attack for my part of the project. What the IP spoofing is, it allows us to disguise our own IP address. This will make it difficult for the victim to identify the attack's origin. And the Smurf attack portion is a type of denial of service, and how we will be doing this is using a Kali Linux tool called hpink3. And what this does is it lets us send a large volume of internet control message protocol packets, which will essentially flood a network or a specific server. If you look at our topology here in GNS3, we have our attacker's network right here. We have the victim's network, PC1, which will be IP spoofing as, and the Smurf attack portion, which will be sending ICMP packets to flood the network, will be up here for at this network up here. Here I'm going to be showing you the Kali Linux tool that we'll be using. So this is called hpink3, and we are using the fast mode. This is the address that we'll be IP spoofing as 192.168.1.2, and the destination will be 192.168.10.2. So just to show you, we'll be spoofing as 192.168.1.2, which is right here, and the destination will be this network, which we'll be flooding. Alright, so let's run the command here. So running this command, we are flooding this victim's network. As we can see here, this is a large amount of ICMP packets. And one strategy to, one mitigation that we could use is if you look at our routers 3, if we use this command, it's an access control blacklist. If we press enter, what we essentially did is we blacklist that IP address from getting to our network up here. If we look at the Wireshark now, here we can see that the ICMP packets have failed, so the mitigation is a success. Our host is unreachable, so that will stop the hpink3 ICMP packets from flooding the server. So that was one of our attack mitigations, which is the blacklist using access control lists to deny the associated IP address from communicating with the network. And in conclusion, we showed the successful attack of the IP spoofing Smurf attack and our mitigation efforts. Thank you for watching.
Hello, my name is Ashwant. These are my teammates. Uh, each of our each of our teammate will demonstrate an attack that can cause IP spoofing and a corresponding defense strategy. I'm performing Teardrop attack, which is a variation of fragmentation attack. So an IP fragmentation attack exploits the routers and endpoints to break large IP packets into small fragments. It specifically targets the layer 3. If not handled properly, this attack can either bypass security mechanisms or cause a system failure. These are my objectives: successfully implementing an IP fragmentation attack to understand the layer 3 vulnerability and explore the defense strategies. So there are two versions of IP networks, IP4 and IP6. This fragmentation and reassembly occurs only in IP4. The main aim of this attack is to gain access on TCP flags. So to implement this attack, we need to install VirtualBox and do virtual machine to simulate the attack, and install the necessary tools like Wireshark. On the attacker machine, we can write the script and run it and monitor the incoming packets using Wireshark on the machine. So let us demonstrate an attack. So first open attacker machine. Let's check my code of airdrop. So this is the Scapy code for teardrop attack. This script implements a teardrop attack, a type of DOS that exploits IP fragmentation vulnerabilities. Some of the key components include these imports. This random function generates random values for payloads and fragmentation of offsets. This is the IP address of a target IP. And for random payload generation, it creates a alphanumeric data of a specified size to simulate the packet data. It generates three IP packets. First fragment with offset 0, second with offset 64, and next one is overlapping fragment different offset. This for loop sends the generated fragments in a loop to overwhelm the target. So let's save it. Enter Control X. Now run the code. We can see here the attacker is sending the packets. Let's monitor on victim machine. It's Wireshark. See here from the source, we can see the IP4 and ICMP packets. So these are my findings here. Before the attack, the CPU usage was around 5 to 10%. After attack, the CPU usage was around 80 to 90%. And I observed the system crash due to resource exhaustion. The packets are successfully captured using Wireshark and victim machine. These attacks can bypass basic firewall configuration. The defense structure includes we can drop the packets with excessive fragmentation or suspicious fragmentation of fragment offsets, and we can verify the fragments with firewall settings that can check the fragment of order and offset consistency. We can also detect the fragmentation patterns through correlation analysis between patterns. So my teammates will continue the remaining attacks. Thank you.